Friends, welcome to my channel. Dhanesh here.
In this video, we will study another very useful model that converts text to numbers, that is the bag of words. Since most of the statistical algorithms, example machine learning and deep learning techniques, work with numeric data, therefore we have to convert text to numbers. Several approaches exist in this regard. However, the most famous one are bag of words, TF-IDF, and Word2Vec. Though several libraries exist, such as scikit-learn and NLTK, which can implement these techniques in one line of code. It is important to understand the working principle behind these word embedding techniques. The best way to do so is to implement these techniques from scratch in Python, and this is what we are going to do. In this video, we will see how to implement the bag of words approach from scratch in Python. Before coding, let's first see the theory behind the bag of words approach. Next is the theory behind bag of words approach. To understand the bag of words approach, let's first start with the help of an example. Suppose we have a corpus with three sentences. I like to play football. Did you go outside to play tennis? John and I play tennis. Now, if we have to perform text classification or any other task on the above data using statistical techniques, we cannot do so since these statistical techniques work only with numbers. Therefore, we need to convert these sentences into numbers. Step 1, tokenize the sentences. The first step in this regard is to convert the sentences in our corpus into tokens or individual words. Step 2, create a dictionary of word frequency. The next step is to create a dictionary that contains all the words in our corpus as keys and the frequency of the occurrence of the words as values. In other words, we need to create a histogram of the words in our corpus. You can see the table. In the table, you can see each word in our corpus along with its frequency of occurrence. For instance, you can see that since the word play occurs three times in the corpus, once in each sentence, its frequency is 3. In our corpus, we only had three sentences. Therefore, it is easy for us to create a dictionary that contains all the words. In the real world scenarios, there will be millions of words in the dictionary. Some of the words will have a very small frequency. The words with very small frequency are not very useful, hence, such words are removed. One way to remove the words with less frequency is to sort the word frequency dictionary in the decreasing order of the frequency and then filter the words having frequency higher than certain threshold. Let's sort our word frequency dictionary. Step 3 is creating the bag of words model. To create the bag of words model, we need to create a matrix where the columns correspond to the most frequent words in our dictionary, where rows correspond to the document or sentences. Suppose we filter the 8 most occurring words from our dictionary, then the document frequency will look like this. In the table it's given. It is important to understand how the above matrix is created. In the above matrix, the first row corresponds to the first sentence. In the first, the word play occurs once. Therefore, we added 1 in the first column. The word in the second column is tennis. Sorry. Sorry. It doesn't occur in the first sentence. Therefore, we added a 0 in the second column for sentence 1. Similarly, in the second sentence, both the words play and tennis occur once. Therefore, we added 1 in the first 2 columns. However, in the fifth column, we add a 0 since the word football doesn't occur in the second sentence. In this way, all the cells in the above matrix are filled with either 0 or 1, depending upon the occurrence of the word. Final matrix corresponds to the bag of words model. In each row, you can see the numeric representation of the corresponding sentence. For instance, the first row shows the numeric representation of sentence 1. The numeric representation can now be used as input to the statistical models. Now let's implement the bag of words model in Python. The first thing we need to create our bag of words model is dataset. In the previous theory, we manually created a bag of words model with 3 sentences. However, real world data sets are huge with millions of words. The best way to find a random corpus is Wikipedia. In the first step, we will scrap the Wikipedia article on natural language processing. Okay, let's first import the required libraries. As we did in the previous video, we will be using the beautiful Soup4 library to parse the data from Wikipedia. Furthermore, Python's regular expressions library, RE, will be used for some pre-processing tasks on the text. Next, we need to scrap the Wikipedia article on natural language processing. So in this script, we import the raw HTML for the Wikipedia article. From the raw HTML, we filter the text within the paragraph text. Finally, we create a complete corpus by concatenating all the paragraphs. The next step is to split the corpus into individual sentences. To do so, we will use the sentence underscore tokenize function from the NLTK library. Our text contains punctuations. We don't want punctuations to be part of our word frequency dictionary. The next script, we first convert our text into lowercase and then we'll remove the punctuation from our text. Removing punctuations can result in multiple empty spaces. We will remove the empty spaces from the text using regex. In the script, we iterate through each sentence in the corpus, convert the sentence to lowercase, and then remove the punctuation and empty spaces from the text. Let's find out the number of sentences in our corpus. It's 47. Let's print one sentence from our corpus. you can see that the text doesn't contain any special character or multiple empty spaces. Now we have our own corpus. The next step is to tokenize the sentence in the corpus and create a dictionary that contains words and their corresponding frequencies in the corpus. In the script, we created a dictionary called word frequency. Next, we iterate through each sentence in the corpus. The sentence is tokenized into words. Next, we iterate through each word in the sentence. If the word doesn't exist in the word frequency dictionary, we will add the words as the key and will set the value of the word as 1. Otherwise, if the word already exists in the dictionary, we will simply increment the key count by 1. If you are executing the above in Spider Editor, you can go to the variable explorer and right click word frequency variable. You can see the dictionary as well. In the Spider here, I am using the Jupyter Notebook. You can see words in the key column and their frequency of occurrence in the value column. As we discussed in the theory section, depending upon the task at hand, not all the words are useful. In huge corpora, you can have millions of words. We can filter the most frequently occurring words. Our corpus has 535 words in total. Let's filter down to the 200 most frequently occurring words. To do so, we can make use of Python's heap library. Now our most underscore frequency list contains 200 most frequently occurring words along with their frequency of occurrence. The final step is to convert the sentence in our corpus into their corresponding vector representation. The idea is straightforward. For each word in the most underscore free dictionary, if the word exists in the sentence, a 1 will be added for the word, else 0 will be added. In the script above, we create an empty list sentence underscore vectors, which will store vectors for all the sentences in the corpus. Next, we iterate through each sentence in the corpus and create an empty list sentence underscore work for the individual sentences. Similarly, we also tokenize the sentence. Next, we iterate through each word in the most underscore frequency list and check if the word exists in the tokens for the sentence. If the word is a part of the sentence, 1 is appended to the individual sentence vector, sentence underscore work, else 0 is appended. Finally, the sentence vector is added to the list sentence underscore vectors, which contains vectors for all the sentences. Basically, this sentence underscore vectors is our bag of words model. However, the bag of words model that we saw in the theory section was in the form of a matrix. Our model is in the form of a list of lists. We can convert our model into matrix from using the script. Basically, in the script, we convert our list into a two-dimensional NumPy array using array as array function. Now, if you open the sentence underscore vectors variable in the variable explorer of the, open that, you can see the following matrix. You can see the bag of words model containing 0 and 1. You can see the array. So bag of words model is one of the 3 most commonly used word embedding approach, with TF-IDF and Word2Vec being the other 2. In this video, we saw how to implement the bag of words approach from scratch in Python. The theory of the approach has been explained along with the hands-on code to implement the approach.
Thanks for watching. Please like, share and subscribe. Thanks a lot.